Lesson 10-8, Polygons and Tessellations. A polygon is a simple closed figure that is formed by 3 or more line segments. So if we have 3 or more lines that are connected together that is closed, this is considered a polygon. A simple figure is one that does not have any lines that cross each other. So if we have something that looks like this, that would not be considered a simple figure because it crosses each other. But something that would look like this is an example of a simple figure. Now, a closed figure is when you have the figure ends at the same point the figure begins. So if we have an example of something like this, where you draw it and it ends at the same point it stopped, that is considered a closed figure. But if we drew something that was like this, that is not a closed figure because it did not end where it began. When we have multiple different polygons, we name them by the number of sides in which they have in the figure. But we want to make sure that we're always counting the sides. Just because it may not look like a simple or a normal figure that we would see that looks like a pentagon or a hexagon or heptagon, we need to make sure that we're counting the sides of each object. So each one of these words ends with the word gon, but I've just given you the prefixes. So a pentagon has 5 sides. A hexagon has 6 sides. So we know what our typical hexagon looks like, but something like this, we could also call that a hexagon because it does have 6 sides. A heptagon is something with 7 sides, and so something like this would work. A octagon is typically a stop sign, but we could also use almost like an inside-out star looking shape. And I'm not the best artist, but that works. A nonagon is something that has 9. And then a heptagon is a decagon is something with 10 sides. So just because it may not look like a normal figure, just make sure you're counting the sides each time to assure that it has a specific number and then give it its name. So regular polygons are the ones that have all the sides are congruent and all the angles are congruent. So an equilateral triangle would be an example of a regular polygon because all of the sides of an equilateral triangle are congruent. That's why it's called equal. And all of the angles are congruent. Another example would be a square because the sides of a square are all equal and the interior angles are all equal to 90 degrees. Now you can see that I used 1 line for the triangle and 2 lines for the square. That's because the sides of the square are not equal to the sides of the triangle, and so I did not want any confusion as to whether these 2 objects were similar or congruent to each other. When we have polygons, we can figure out the interior angle measure of those polygons based on what we know about triangles. So let's start out with a polygon, and we know that polygons have 5 sides. So we have a picture of a polygon. So what you do is you take a vertex and you create triangles from that vertex. So our first triangle is there, our second triangle is over here. So we see that we have 3 triangles. Well, we know that each triangle adds up to be 180. So you take the number of triangles and you multiply that by 180 to equal the total of the angles of the polygon. So in this case, we have 3 triangles times 180 is going to equal 540. So the total interior angles of this pentagon is 540. But we want to know what one angle is. So you take the number of angles of the polygon and divide your total by that number. So we would divide 540 by 5, and that would get 108. The last part of this lesson is going to be about tessellations. A tessellation is a repetitive pattern of polygons that fit together with no overlaps or holes. You're going to actually be completing a project that's using tessellations where you'll get to create your own tessellation using a variety of polygons. But we are going to look at how to determine if a polygon can create a tessellation. So let's go back to our normal pentagon, and this is a 5-sided object. And so let's say we know that this interior angle is 108. Well, when we think about tessellations, the angle of all of the shapes that meet at a particular point has to equal 360. So what that means is that we can take this angle measure and multiply it by how many ever number of objects we have to equal 360. Well, we want to figure out how many pentagons can be put together to equal 360. So we can divide both sides by 108, and we get n equals 3.3. Well, we know that we cannot have 3.3 of a shape, which means that you are not able to use the pentagon to create a tessellation. Pause the video to complete the lesson review. Make sure you show me this lesson review for verification of watching this video.